Welcome to my YouTube channel Raise a Cat, and today we will see in semiconductors topic in physics what is the concept of p-type doping and n-type doping. Okay, so in this semiconductor topic this is very important to know that what is p-type doping and what is the concept of n-type doping. Okay, so these are the two kinds of doping, p-type doping and the n-type doping. So in the p-type doping, what is there? Suppose that there is some material. So in this p-type doping, suppose that this was the initial material, okay, and in this we will insert a material or the element. Suppose that there was an element, suppose that silver, okay. So silver was the element, initially the silver was the element, and in this silver we will be inserting some element if we are doing this p-type doping. So what we will do in this p-type doping, we will insert the elements which can accept the electron, okay. So suppose that any element from the periodic table we will select which can accept the electrons, okay, and we will insert in this, okay. So how the doping is done? Doping will be done in the empty spaces in the structure of the element, okay. So suppose that Ag is there in the form of AgCl. So the structure of AgCl will be something like some structure will be there, some type of packing will be there in the AgCl structure. So in that packing in the AgCl structure, in the stoichiometry we study that what and all are the structures and all, okay. So what and all is the structure of the AgCl. We will insert the element in that, suppose from the periodic table any element which can accept the electron, okay, or which has the tendency to accept the electron, and we will insert that element in the empty spaces in that structure, okay. So there are BCC, FCC and SCC, okay. So in the BCC, suppose that it has a BCC structure or FCC structure. So in these the empty spaces are there or the void fractions are there. Void fraction are there in any geometry. Some void fractions are there. So in these void fractions we will insert the elements or the atoms which from the periodic table which can accept the electron, okay. So the new element will be formed like this. So the initial was AgCl and the new element which can accept the electron. So this is the structure of the new element, okay. So now this has tendency to accept the electron. So what is the benefit of doing p-type doping? That now it can accept the electron. AgCl, which was having less tendency to accept the electron, will be having the more tendency to accept the electron, okay. And how we will choose what type of element to dope? The element can be doped only when it can go in the lattice positions or the empty positions in that element. Suppose that the void fraction or the space or the position in which it is going has a less space, okay. So and the element which we are doping is larger in size, so it cannot go in the empty space, so we cannot do p-type doping. P-type doping can only be done if the element which we are doping has a less size and can go in the interstitial positions in the element, okay, or the initial element in which we are doping, okay. So like this we will see what type of element to dope in the p-type doping, okay. So like this we will choose what type of element to dope in the p-type doping, okay. So now we will see what type of element to dope in the n-type of doping, okay. So we will see what is n-type doping. So suppose that this was the structure of the initial element, okay. So if we will insert that element which can give the electrons, okay. So it has if we are doping the element which has more number of electron, okay, or in the minus state, okay, A minus, okay, if we are doping this element, if we are in this we are doping, we are doping the A plus type of element, okay, A plus type of element was doped in this. In this, what type of element is doped? A minus type of element is doped in this case, A minus. So what is the A minus? Minus is the electron. So now the element, suppose that we are taking the initial one only, AgCl. So AgCl will be now having the more tendency to give the electron, okay. So these are in this the p type doping, these what we are inserting the here, these are termed as holes. Holes. Why holes? Because these holes can accept the electron, okay. So that's why they are also p type doping. In this the structures which can accept the electron are also termed as, spaces are termed as the holes, okay, because they are can accept the electron, okay. And in this, what it can do, they can give the electron, okay. So they are the n type doping, okay. P means positive, okay. So these are the positive elements because they can, and because they are, we are doping this A plus type of element, so they are positive type of doping, okay, because A plus, and here this is n type of doping because A minus is dope, so negative, okay. So this is the n type of doping, okay, because now this structure or the newly formed structure can give the electron, so that's why it is called as the n type of doping, okay. So now the newly formed structure can give the electrons, and the concept is similar that if we are doping any element, so that element size should be less than the size which is available, okay. So void fraction in the AgCl type of structure, okay. So there are three type of structure, BCC, SCC and FCC, okay. So in that structure, the void fractions which are there should be should have the space or the size more than the size of the element which we are doping. So then only the element can go in the initial interstitial position, else it will form a complex, okay. So if it is not having space, what it will do, AgCl is supposed that this and A minus is this, so AgCl A minus, like this structure it will form. It will form a complex, okay. It will not do doping, okay. So it will not do doping. What is doping? In doping, the element goes inside it. In the complex, it will not go inside it. It will just bind with it, okay. Bind with it means like with a bond or the ionic bond. With the ionic bond, it will be connected to this, but it will not go inside this. But in the doping, what it will do, it will go inside the element. So then only we will say that we have doped an element, okay. Else it will just form a complex. If it will be not able to go inside it, so it will just form a complex, okay. We will say that the element has gone inside it only when it has a size which is less than this, okay, as it will form a complex. So this structure will be called as the complex. So the properties of this will be not same as this, okay, because this bond can be easily broken, complex bond can be easily broken, and this A can be removed. But this, if the A is gone inside it, this cannot be removed, because this is the new element which is formed. It has gone in the interstitial position, so it cannot be removed from this element. So this is the benefit of doping, that we cannot remove this. But if we form the complex with this and this, so this complex, this A minus can easily be removed and its properties can be changed. So suppose that there is high temperature, so in the high temperature this A minus will not be coming out from this, but this A minus, which is in the form of complex or the ionic bond, can easily be broken. So these are some of the advantage which is from the doping, okay. So we have seen what is the p type doping, what is the n type doping. So these were the concept for the both n type and p type doping, and what are the advantages of the doping over the complex formation, okay, and what are the differences in complex formation of any element with another element, and what is the difference with the doping of that element in the particular element. So this we have seen in this. Okay, thank you.